So in this case, let's talk about our important topic. Um, okay, let me erase this. So our important topic, that is the first one. So I'll increase the width of this, okay? So that will be useful. So the first one, that is how the diode characteristics looks like. So because since I would like to teach from very basic, so one should be very strong in basics, okay? So understanding the concepts. So here, so the diode, if you see carefully, so if you see carefully, the diode is a combination of two elements, p-type and n-type. So p-type material and n-type material, it's a combination. So now in the p-type material, majority are the holes. In the p-type material, majority are the holes. In the n-type material, majority are the electrons. So now what actually happened is, so there will be lot of holes at this place, there will be lot of electrons at this place. I am not drawing entirely, assume there is an entire thing in entirely distributed across in these regions. Now this p-type material is given with a positive supply. Okay, this p-type material is given with a positive supply and this n-type material is given with a negative supply. Now this positive and this is negative. So assume this voltage is a variable voltage. So variable means it will vary from 0 to say 5 volts approximately. Let us take that value. Now so if I see the ammeter, so let me put an ammeter here so that the voltage and current. So I'll put a ammeter here where it will measure the current, and I'll put a voltmeter here where I'll put a voltmeter here, so where it will measure the voltage. Okay, now see, so our main intention here is to draw the IV characteristics of this particular diode. So let first draw a line. Okay, in this one, so you take on the x-axis the voltage, that voltage in volts, on the y-axis, so let me write current in amperes. So now let us assume that there is something like this is 2 volts. So now, and let us assume this is 1 volt. So I have assumed that I have given a slight change in the voltage. Okay, I have given slight change in the voltage. So voltage I slightly varied to 0.1 volts. Now with this 0.1 volts, this will be pushed slightly towards because this positive and this negative, positive will repel because this all this p-type material is positively charged, and hence this positive charge will be pushed here, and at the same time this negative type, this negative terminal is negatively charged, so negative will be pushed slightly, but it doesn't have enough force to cross this junction. There will be a junction, isn't it? So at the time, so whatever the voltage that you see, the same voltage will be appear, but the current is 0. So here there won't be any current. Now slowly you increase the voltage to say 0.2 volts. Even if you go to 0.2 volts, the scenario is the same. 0.3 volts, 0.4 volts, 0.5 volts, 0.6 volts, 0.7 volts. So whenever it reaches to 0.7 volts, a slight amount of current that started flowing because this holes will try to jump, these electrons will try to jump here, so the recombination will occur and the current starts flowing through this, electrons will start moving through this, because okay, so this combination will takes place. Now you go on increasing the voltage, so you can see an abrupt increase in the current. So this is the very important characteristics of a diode. So you observe carefully. So it looks like exponential curve increment. This portion, this region of improvement is the exponential curve improvement. So that is how that we have to be very careful in looking here. That so now when the voltage starts at 0.7 volts, it started conducting and going on, and whenever it is going on further increasing, maybe 0.8, 0.9, even less than 1 volt, it start increasing the current. So these characteristics are called forward bias diode characteristics. So now if you talk about, some people will talk about the reverse bias characteristics, like, so you may think like what will happen in case if I am giving a voltage of positive voltage this side and negative voltage this side. So for example, if this is the positive voltage and this is negative voltage, what will happen? So all these electrons will attract here, all these holes will attract here, so there will be a large gap, but what will actually happen is there will be some electron, there will be some hole here. Due to, so when you try to increase the voltage, negative voltage go on, so at certain point it will start breakdown and it will start incrementing. So the point at which the breakdown occurs is a diode breakdown voltage. So we have to be very careful while we are doing the reverse bias condition, because in the reverse bias in the sense what? When the P terminal of the device is connected to negative and then N terminal is connected to positive, then the diode is said to be reverse bias. When this is the reverse bias condition, so the diode never acts, but if you forcefully try to make it act, then the diode will try to act, and it'll I mean permanently it will be damaged, and there won't be any further questions on that. I mean further on this diode, because the diode is damaged, we can say. That's the reason why generally we give the positive voltage to diode to conduct in one direction. So negative voltage we generally don't give.